Okay, the next process up is completing the square, and the idea is to take any quadratic and write it as a perfect squared, sort of or kind of like this right here. If I take this quadratic, this is really x squared minus 10x minus 175 equals 0. This is prime. And somebody made the connection between that and completing the square. They said if you go back, if you complete the square, you could make any quadratic into a perfect square and you could use the square root property. And that turns out to be a massive deal for us. The catch, this has to be a positive one. And this is how the process works. If you take x squared plus 8x and I'm going to take my steps in the first problem. So this has to be a positive one. If that is a positive one, what you're going to do, you're going to add a number to both sides of the equation. So that's why you want the x squared and the x on one side. And the way it's going to work, you're going to take half of the middle number every single time, and you're going to square it. That's the process of completing the square. You're going to add 16 to both sides. Now, if you notice, if I factor this, this will always become a perfect square if you factor it by hand. X, that sign, and the number before I squared it. And the right side will be a 24. So if you take x plus 4 squared, that would be x squared plus 2ab, 8x plus b squared, which is 16. That happens all the time. And now that I have a perfect square on one side, everything else on the other side, I would square root both sides. I'll get x plus 4 to equal plus or minus. This is 4 times 6. This clears the radical, the 6 remains. Move the 4 over. And instead of saying this is prime and cannot be solved, now you could solve any quadratic. So this only applies to quadratic equations. And in case you've forgotten, quadratic means ax squared plus bx plus c equals 0. So again, another one of those. If they say complete the square, you must solve by completing the square. To complete the square, this must be a 1. It's not. You could force it to be a 1. Very easy. So this is x squared. Negative 6x over negative 3 is a positive 2x. I'm going to add a number to both sides of the equation. Negative 1 divided by negative 3 is 1/3. And here it is. Now, I'm going to take half of the middle number. I'm going to take half of 2, which is 1, and square it. This left side becomes a perfect squared. You could factor it on the side if you really wish. 1 and 1, 1 and 1, add up to give you 2. So however you factored, you're guaranteed you're going to get x with that sign and the number before you squared it. The right side, I need to get a common denominator. LCD is a 3. 3 plus 1 is a 4. And now that I have a perfect square equal a number, I could always use the square root property. Square root of 4 is 2, square root of 3 is 3, and I do need to rationalize, multiply top and bottom by the same index radical. So I'll get x plus 1 equal plus or minus 2 radical 3 over 3. And if I move the 1 over, that will tell me x equal negative 1 plus or minus 2 radical 3 over 3. And I'd like to add an example. There are only 2 problems in the book, and I thought I will do one more. Again, I need the x squares. So assume this is 16 prime. I'm going to move the x's together and the numbers on the other side. 26 minus 7 is 19, I think. Yeah. So I'm going to add a number to both sides of the equation. I'm going to take half of the middle number and I'm going to square it. This becomes a perfect squared. X with that sign, the number before I squared it, 19 plus 1 is 20. And if I use the square root property, x minus 1 will equal plus or minus, this is 4 times 2, 4 times 5. So this clears the radical and you have a 5 left over. Move the 1 over and there it is. Alright, now if I complete the square, that's one method. Another trick I could use, given ax squared plus bx plus c equals 0. So if I have everything on one side, 0 on the other side, x will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. This is called the quadratic formula, the famous quadratic formula. There's only one example in the book for you to use it. Again, they're assuming this is a reminder of this. That's why they're not covering this in full detail. So I added 2 more examples. If I'm looking at this and it says solve each equation by using quadratic formula, you must get everything on one side, 0 on the other side. A is 3, B is 2, and C is 1. And W will equal negative B, negative 2, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. W will equal a negative 2 plus or minus. The catch with this, you got to clean up the radical. That's why I prefer completing the square. This is a 4 minus 12 over 6. W will equal a negative 2 plus or minus. 4 minus 12 is a negative 8. And W will equal negative 2 plus or minus. This right here gives an I. And isn't that 4 times 2? 4 clears the radical as 2. And if you remember, we have to separate, we have to split those up to get the part that's real and the part that is complex. I'm just going to shift this to the left a bit. Okay, that didn't work. And now I'm going to say W is going to equal negative 1/3 plus or minus 2 divided 3 times radical 2 over 3i. That would be my final answer. Rearranging the furniture. Alright. So, let me take this next problem. Again, I prefer completing the square anytime over quadratic formula because cleaning this radical is a big mess. If I write this, I assume this is 18 prime. Again, an example that I made up. If you take 4x squared plus 12x minus 5 equals 0, and if you use the quadratic formula, x will equal negative b, b is 12, plus or minus the square root of b squared, 12 squared, minus 4 times a times c, all over 2 times a. X will equal negative 12 plus or minus the square root. That's 144. This is a positive. 5 times 2 is 20. 20 times 4 is 80. And this is 4, 12, 224 divided by 8. Again, Cleaning the radical is a big hassle. That's why I really don't prefer using the quadratic formula, but students disagree. If I take 224, and I'm trying to think, 2 divides 112, 2 divides 12 5 times, you have 56, so there's a 4 in there for sure. And this is 4 divides 5 1 time, 4 divides 16 4 times, so there it is. This is actually 16 times 14, 4 radical 14 divided by 8. And if I split this up, that would be wise to do. X would be a negative, divided by 4, that is 3 over 2. Divided by 4, that's radical 14 over 2. You could combine those, you could leave it as is. Number 22 is next. It says, at a tennis club, a 15,000 square feet. Since that's square feet, they're talking about area, this whole area. Rectangular area is partitioned into 3 rectangle courts of equal size. They're all equal. So if you call this the W, this is the same, this is the same, and of course the length is the same for all of them. A total of 800 feet of fencing. That's everything that you see. That's where we're going to use the fencing on all of those. There. That's what you're going to fence. Everything around that will be used to enclose the 3 courts, including the interior sides where we did that. What are the possible dimensions in feet of the entire rectangle? They want to know entire rectangle, 3W times L. So first we start by saying, well, look, area of this is length times width. Area is length times 3W. It's really 3 times the length times the width. And the perimeter, if you look at the perimeter, that's going to be one W, 2W, 3W, 4W, 5W, 6W, plus 1L, 2L, 3L, 4L. And that equals a total of 800. So this is like 2 equations to unknowns from back from algebra. And this area we said was 15,000. So length times width is actually, if I divide by 3, is 5,000. So I have a system of equations. I don't know if you remember that from back in the days. Let me refresh your memory really quick. If I use substitution, if I solve one of those, let's say I solve for L. If I take this and I say, well, look, this says 4L equal negative 6W plus 800. And if I divide by 4 each of those, I'll get L to be a negative 3W over 2 plus 200. And I would substitute that in the first equation. Get rid of that L. So here we will get L, which is negative 3W divided by 2, times the width equal 5,000. I forgot the 200. So if I take all of this and put it right there, that would be there. And now, if I clear this up, you know what? I could organize this a bit nicer. Right there. Right there. Take this and put it right there. And what I'm really looking at is this. this would be negative 3w squared over 2 plus 200w equal 5,000. And you notice that this is a quadratic equation. I need to solve it. So if I clear the fractions, this is over 1, this is over 1, LCD is a 2, multiplied by 2 top and bottom, by 2 top and bottom, this will be 400w equals 10,000. I'm looking at 3w squared minus 400w. What I did, I moved those two to the right, plus 10,000 equal to 0. And to factor this, I'm going to think of what? 3 and 1. Closest factors of 10,000, I'm going to say 100 and 100. I want them to add to get me 400. 300 plus 100 is 400. That works. 3w minus 100 and w minus 100 equals 0. So 3w minus 100 will equal 0. W will be 100 over 3, or w equal 100. So when they say, what are the possible dimensions of the entire rectangle? If I use this, remember that's the width, I'm going to say the dimensions or possible dimensions are if I take 3 times 100 over 3, that would be 100 by, and what would be the length? The length is right there. I need to plug that in. I'll get a negative 3 over 2 times 100 over 3 plus 200. Those cancel out. And this divides that 50 times. Negative 50 plus 200 will be 150 feet. Or it could be if I put this right here, it could be 300 by, if I use that to figure out the width, I'm looking at negative 3 halves times 300, no, times 100, I'm sorry, W is 100, times 100 plus 200. This simplifies into that 50 times negative 150. A negative 150 plus 200 is a 50. So those both multiply to give you 1500. Those are the possible two dimensions of this rectangle. The last problem I'd like to look at is problem number 24, and it says a ladder leans against a wall. It says a ladder of length 2x plus 1 is positioned against a wall. Let's say this is the wall, and the ladder looks like this. There's the ladder. And the length of it is 2x plus 1, such that the bottom is x minus 1 feet away from the wall. The bottom, this is the bottom of the ladder, is x minus 1 away from the wall. The distance between the floor and the top, the distance between the floor and the top of the ladder is 2x. Everything's in feet. Find the length in feet of the ladder. Assume that the angle formed with the wall and the floor is 90 degrees. That's always the assumption unless you tell you otherwise. And what do you know about this? I know this is using Pythagorean theorem. 2x plus 1 squared equals 2x squared plus x minus 1 squared. So 4x squared plus 4x plus 1 equal, this is 4x squared. And if I FOIL this, x squared minus 2x plus 1, combine like terms, 4x squared plus x squared is 5x squared. And if I get 0 on this side, everything else on the other side, subtract 4x squared from both sides. Subtract 4x from both sides. And when you subtract the 1 from both sides, that cancels out. And you notice that that becomes a quadratic. So either x equals 0 or x equal x minus 6 equals 0. That means x equal a 6. Well, x equals 0 doesn't make sense because then the height will be 0. So x equals 6. That's what we got. They're asking, find the length of the ladder. The length of the ladder is 2x plus 1. If you substitute a 6 in there, that will be 2 times 6 plus 1, 12 plus 1. The length of the ladder is 13 feet. And that pretty much concludes this section.